Now let's start our journey into vectors. So the first thing we want to ask is, what is a vector? And here is the definition here. A vector is a quantity with both magnitude and direction. Now by magnitude we mean size. So let's look at some examples of vector quantities. Force is a vector quantity. So let's say for example we have a little ball here. If we were to apply a force directly onto the ball, common sense will tell us that the ball will roll in this direction. But if we were to apply a force at a different angle, then the ball would move in a different direction. So it means that the force here not only has got a magnitude, so for example it might be 20 newtons, it also has a direction associated with it. Velocity is also a vector. So let's say for example we were to drop a leaf into a flowing river. Now depending on where we drop the leaf, it's going to travel in a particular direction. So here's a few spots where we could drop the leaf into the river, and you can see the leaf is going to travel in these directions here. But depending on whereabouts the river we drop it, the leaf is also going to travel either fast or it's going to travel slow. So the length of these vectors here, these lines, will tell us how fast the leaf is travelling. So if the line is long here, then it tells us that the leaf is travelling quickly if it's dropped in at this point. So we can see here that the velocity here has both got a magnitude, so it's got the size here 5 meters per second, but it's also got a direction associated with it. Now let's look at mass. Mass isn't a vector quantity, mass is only a scalar quantity. It's got no direction associated with it, all it's got is a magnitude. So for example, the magnitude of this mass here is 10 kilograms. Now we want to be able to represent these vector quantities mathematically, so that's what we're going to look at next. So how do we represent the magnitude and the direction of a vector? Well, I've drawn out 4 vectors here, and you can see that the magnitude is going to be represented by the length of the vector, and the direction is going to be represented by the arrow. Now there's a couple of ways that we can name the vector. We can put a letter at the beginning and the end of the vector. Therefore this vector here would be called AB, but note, to represent the fact that it's a vector, we'll put a little line across the top here. So this is vector AB. Now if this arrow had been pointing in the other direction here, then the vector would be called vector BA. Now there's another way that we could name the vector, is that we can use a single letter for it. So for example, I could call this vector just vector U with a little bar. So we could say that vector AB is the same as vector U. Now this doesn't contain all the information we want to know about a vector, because we don't know what the actual length of this is. We have to be able to represent it somehow. So we can represent it in something called component form. So we could say that the vector AB is equal to the vector U, and then we could use this bracket system here, and the top one would be the x distance and the bottom one would be the y distance. So for example, if we were to take this vector here and reproduce it down here, then we can say that this vector is created by going 2 units along in the x direction, so we put the 2 here, and 1 unit in the y direction, so this becomes 1. So this would be the component form of this vector. So now let's see how we can get the magnitude from this component form. We can say that the magnitude of the vector, now to represent the magnitude we've got the little lines either side, so this represents the magnitude of the vector. So the magnitude of the vector AB is equal to the magnitude of the vector U, they're just the same thing. And it's going to be, well, we simply use Pythagoras. The length of this here, which is the magnitude of the vector, is going to be 2 squared plus the 1 squared, and we take the square root of it. So it's going to be 2 squared plus 1 squared and the square root, so the length of that is going to be root 5. So if we were to generalise this, we could say that if we had any vector PQ, then we could represent the PQ in component form as just a value of AB. So the A would represent the x distance and the B would represent the y distance. And then we could say that the magnitude of this vector PQ would be equal to the square root of the A squared plus the B squared. So that's just exactly the same as we have above here, but we've just generalised it for any vector. The last thing we're going to look at in this video is when vectors are equal. Well, it's hardly surprising that we can say that vectors are equal when they have got the same magnitude and direction. So we have got two vectors here, vector u and vector w. Now the vectors sit at different physical positions. This vector's up here and this vector is down here. But these vectors are equal because they've got the same direction and they've got the same magnitude. So they go along 2 and up 1. That's along 2 and up 1. So they've got the same magnitude and the same direction. Therefore these vectors are equal. So that's all we're going to talk about regarding vectors in this video. We'll continue on the next video. Thank you for listening and goodbye.